So we're here on the campus of University College Dublin in Ireland, just outside Dublin, and it's a beautiful day. I'm with Antonio Martin-Carrillo, an astrophysicist here, who is holding a scale model of the IRSAT-1 CubeSat mission, which will be, when it launches, hopefully later this year, will be Ireland's first satellite ever in orbit. And Antonio has been telling me that Ireland is, although it's a member of the European Space Agency, it has a hotbed of new space startups which are using data, but also who are probably going to be launching their own satellites eventually. Tell us what IRSAT-1 would do.
So IRSAT is a 2U satellite, and it has 3 different detectors or different experiments. The main one is called GMOD, and it's a new technology to detect gamma ray bursts or gamma rays from space, aiming at the study of the explosions of massive stars called gamma ray bursts. Then we have this coating things here developed by a company in Ireland. White reflects light and black absorbs light. So that means that we can build better protections for satellites. And the last experiment that we have on board is a new system to stop the wobbling of the satellite, to keep the attitude fixed and point to the specific part of the sky that we want to point at.
And basically, you're hoping that IRSAT-1 will be able to democratize the observation or detection of gamma ray bursts, which are difficult to detect. But the technology, since Integral and Swift missions, the Integral and Swift missions were launched, has been updated quite a bit. And what you're hoping is that in short order, after IRSAT-1, you will be able to launch a constellation of CubeSats at very low cost, on the order of what, 10 to 20 million euros?
For the whole constellation, probably, yes. So what we're hoping is that our IRSAT is going to put the foundations of a new type of gamma ray detectors that are faster to develop and faster to put in space, test new technology, and at the same time get more satellites that are more capable of detecting gamma ray bursts associated in some cases to gravitational waves, and to study the universe, especially the most violent universe.
And so this is just the opening gambit of what you hope will be a whole new view onto gamma ray bursts, the most powerful explosions known in the observable cosmos. Is that still correct?
Since the Big Bang, yes. So they are the most powerful explosions since the Big Bang.
Since the Big Bang, obviously, you know, that's a biggie.
Yeah.
But and to date, we have not detected one within our own Milky Way galaxy, but you're hopeful.
Well, I don't know. I don't know if we want to experience that. I mean, recently, actually, we detected one far away, but it was strong enough that on our magnetosphere we saw a little blip when the gamma ray radiation hit the magnetosphere. So we can see, we can feel, and with the instruments that we have currently, notice that that impact of the gamma ray radiation coming into us. So I don't know if a galactic one will be too much.
But a galactic one, I mean, you happen to mention that we only seem to get a galactic supernova not that often. The last one was 1987A, I believe, if I'm not incorrect.
But that wasn't in our galaxy. That was.
That's right. You're right. That was in the
Magellanet clouds.
That's in our neighboring dwarf galaxy. But within our galaxy, what was the last one? I don't even have it off the top of my head.
It's a bit more. So I think, if I remember well, it's about every 1500s or so years we should expect a supernova. Now there are different flavors of supernovae, and the ones that creates these jets that power the gamma ray radiation are a little bit. They are just a small fraction of all the different type of supernovae that there are that we know. So we are probably due a galactic supernova, but it could be of any of the different types, and most likely will be a type 1A, which involves a white dwarf star orbiting another star.
But I just want to reassure people that don't lose sleep at night over a gamma ray burst within our galaxy, because it's very unlikely in our lifetime.
Very, very unlikely.
So thank you so much, Antonio. Good luck with the project, and we're looking for launch later this year.
Thank you very much.
Bye-bye.